So now let's take a deeper look at subnetting and see if we can find out our number of subnets, our number of hosts, and use our math here and actually break it down into the binary. So let's check out our important math first. Now when we're talking about our number of subnets, we're using 2 raised to the power of our added bits. So what do we mean by added bits? Well, we need to think about our default Class A, Class B, and Class C subnet masks. And we take our default Class A, B, and C subnet masks and we compare them on the binary level to our new subnet masks. So our default Class A subnet mask would be 255.0.0.0. Our default Class B subnet mask would be 255.255.0.0. And our default Class C subnet mask would be 255.255.255.0. Each of these subnet masks correspond with the IP addresses which we've specified as either being Class A, Class B, or Class C IP addresses. Now, in the example that we showed a little bit earlier, where we had 255.255.255.240, we were modifying a Class C IP address subnet mask. So we were taking that subnet mask and we said, okay, our default subnet mask for Class C would be 255.255.255.0. In binary, that would show up as 111111 all the way down into our last octet, which would be 00000000. But we changed our last octet when we did our subnetting. We changed our last octet, instead of 0, it's 240. Now how would this appear in binary? Well, we added bits to this octet in order to make it 240. We don't add bits from right to left, we add bits from left to right. All of our previous bits were 11111111, so we're just going to continue on. So we add the bits from left to right. So our first bit, and let's actually break this down into our chart. We have our our ones place, twos place, 4, 8, 16, 32, 64, 128. So we need to get to 240 because that's what our new subnet mask is. So we add a bit to the 128 place and we say that's not enough. We add a bit to the 64 place and we say, okay, what do we have now? We now have 192, so that's not enough. We add a bit to the 32 place and we say, well, 192 plus my new 32, that's going to give me 46. So, excuse me, 26. So we have 192 plus our 32 would be 224. And then that's still not enough. We're not at 240 yet. But if we add 16, we'll be there. So 224 plus 16 will be my 240. So we've used 4 bits. We've added 4 bits. Our default binary for our last octet was .000000000. But now our subnet masking, our subnetting has changed this last octet to 240, which equates to 11110000. So the number of subnets that this gives us is 2 to the power of added bits. So 2 to the power of 4, not 2 times 4. 2 to the power of 4 would be 2, 4, 8, 16. So we now have 16 added subnets. What about the number of hosts in each of those subnets? Well, the number of hosts in each of those subnets is the number of off bits minus 2. Luckily, we have the same number of added bits as we do off bits being our remaining host bits. So our remaining host bits minus 2, 2 to the power of remaining host bits minus 2, will be 16 minus 2. Minus 2 because we subtract our network ID IP address and our broadcast IP address, our broadcast ID IP address. So we have 16 potential subnets and 14 usable hosts in each of those subnets. So let's throw it all together, the math that we did in our previous segment and the math we did now. Our network increment is going to be 256 minus n, n being our first non-255 subnet mask portion. So that was, in our previous example, 255.255.255.240. So 256 minus n, 256 minus 240 leaves us with 16. So that's our network increment. We increment our network by 0, 16, 32, 48, etc. Our first, we increment our network by those increments of 16, and each of those first increments are our network ID. So 0 is our network ID, 16 is our network ID, 48 is our network ID, or 16 is our network ID, 32 is our network ID, 48 is our network ID, and on and on. Our number of subnets is going to be 2 to the power of added. So 2 to the power of our added bits, which in this case comes out to be 16. So this is why this one's a bad example. Or the next one will be a little bit better example. So these are our subnets. So we have 16 is our increment. It's our number at which we increment our IP addresses to create our different subnets. Our subnets, we have 16 total subnets, so 16 little new networks that we can divide up our IP address range into, or our standard IP address into. And we have 2 to the power off bits in our host remaining, so 0 minus 2. So in each of our segments, we have 14 usable hosts. So we can have no more than 14 devices which have IP addresses in each of those subnets. So that's our important math, and we threw it all together to get our network increments, our subnets, and our hosts. So let's now take a look at our example. So when you see an IP address or you see an example of a network that's been subnetted, you'll typically see it with the CIDR notation. Now, we talked about our CIDR notation, and we talked about how we take our CIDR notation and how we transmit and how we transfer that and translate that over into a standard numerical subnet mask. So let's take a look at that again. So our -25 means that going left to right, we add in 25 ones into the octets and separate them into octets. So my ones are probably going to be pretty small and might run off into our next section, but that's okay. So in binary, a -25 CIDR notation on a 192.168.10.0 IP address will translate to 1111111111.111111.111111.00000. So each of these sections are octets. We've talked about how our octets work with our IP addresses. And we have 8, 16, 24, and 25 ones. And then the rest are zeros. Now, how do we translate this into our non-binary subnet mask? Well, when we have all ones in an octet, we automatically know that that's 255. All ones in an octet is 255, just like all zeros in an octet is 0. So 255.255.255 dot. Now we need to break out our little chart. Our last octet, let's write it a little bit bigger. And not over here. So our last octet is 1, 0, 0, 0, 0, 0, 0, 0. That's our last octet. So how do we find out what number that equals? Because it's not all ones. We break it out into our chart. and we increment the lowest. This binary digit is either a 0 or a 1. So it's the 1's place. It's either a 0 or a 2, so it's a 2's place. Then we increment up 4, 8, 16, 32, 64, 128. We have a 1 in the 128 place, so this is 128. The rest are zeros. So that means, what does that mean, guys? That means our last octet in our subnet mask is 128. And the rest are zeros. So if we're looking at a subnet mask, that will typically be our lowest number subnet mask octet other than 0. And that's why. Because when we're adding to our subnet mask using CIDR notation, we're adding to our subnet mask and incrementing additional bits. We never increment subnet mask bits. Let me get rid of these because they sort of look like ones. We never increment subnet mask bits from right to left. We always increment them from left to right. And our very first bit from our left is 128. So even if we only have one additional bit in an octet from a subnet mask, it's going to be added on that far left 128 spot. So if we have a subnet mask that's 255.255.255 dot something, that next something will be 128. Or if we add another place, it's 64, or it's 192. Or our next place would be 32, and 192 plus 32 would be our 224. So our subnet mask, when we're doing subnetting, can't just be any random number. We can't have 225.225.225.36 or 37 or 50 because that doesn't work. So we have to know the binary to understand why that is. And the reason is because we're going left to right on our octets. Okay, so we have our IP address, or we have our standard, not our IP address, but we have our first network ID, 192.168.10.0. We have our CIDR notation, which is /25. We translated our CIDR notation into binary, which is all ones and then a single one in the last octet. We translated our binary of our subnet mask into a standard form subnet mask, which was 255.255.255.128. Now we need to figure out the information about our subnets. So, information about our subnets. We have our extra bits. Now what do we mean by extra bits? Well, we talked about how our extra bits are the number of additional bits we added to our subnet mask that weren't there before. So CIDR notation makes it easy for us. If we see a -25, we just have to work, we only have to work forward from that point. We can translate it directly into binary and then create our subnet mask. If we were given this number, if we were given a subnet mask of 255.255.255.128, then it's a little bit trickier to translate that over into our binary. But we talked about in an earlier section how we can do that with our chart. So we found out that the number of extra bits affects this last octet because this is a class C address. 192.168.10.0 is a class C address. So its standard subnet mask would be 255.255.255.0. We added one bit. This says 128, but we still only added one bit to that last octet in the binary. So extra bits is 1. Now host bits off. What do we mean by host bits off? Well, the rest of this octet are host bits, and they're not turned on. They're not ones, so they're off. They're zeros. So there's 7 of them. So we have one extra bit that we added from our standard 255.255.255.0. We added one extra bit to make that .128, and we still have 7 host bits that are off. So we have 7. So now we need to find out, and we'll separate this again. So we have our numbers, some of our numbers that we need. Now we need to find out our subnets. How many subnets do we have? Well, it's 2 to the power of added bits. So we added 1 bit. So it's 2 to the power of 1 equals 2. So using this CIDR notation, using this subnet mask, we have 2 additional subnets. Or we have 2 subnets now. Next, we have our number of hosts. And our number of hosts are going to be 2 to the power of off bits minus 2. So we have 7 off bits. And 2 to the power of 7 is going to be 128. So 2 to the power of 7 is 128. Minus 2 is 126. So the number of hosts that we have per subnet is going to be 126. So in each subnet, we have 126 potential hosts. Not as much as 255, but it's still a lot in certain situations. Not an enterprise situation, but a small business or home it would be. So we have 126 hosts per subnet. Now we need our increment. Now our network increment we talked about earlier is going to be our 256 minus this number. So we have our 256, and let's move this just to get a little bit out of the way, equals 126. So our network increment is going to be 256 minus our 128. Our increment number is going to be 128. We know the number of subnets. We have 2 potential subnets. We know the number of hosts per subnet. We have 126 hosts per subnet. And we know our increment for our subnet. We know where we increment. It's going to be at 128. So our first subnet will be 0 through 127. And then our next subnet will start at our next increment, 128. And then we'll go 128 all the way to the end. So because we can't start a new one at 256 because that's our highest number. So we have 2 subnets. We have 126 hosts per subnet, our increments, and our network ID for this segment will be at 192.168.10.0, and we'll also have another starting at 192.168.10.128, and then our broadcasts will be, we'll put in our broadcasts here. Our broadcast addresses will be 192.168.10.127 for this address range. So our first subnet will be 0 through 127, but we can't use those, remember? And then we have 192.168.10.255 for our second subnet's broadcast ID. So what about our hosts? Well, our hosts are going to be anything in those subnets that's not a network ID or broadcast ID. So in our first subnet, we have 192.168.10.1 through .126, and then we have .129 through 254. After much thought and much explanation and a bit more math than some of us may be initially comfortable with, we were able to take our IP address here. We were able to use its CIDR notation and break that out into the binary. Use our binary to find our subnet mask. Break down our subnet mask and find how many extra bits we had. Our host bits that we had off. Use those extra bits and those host bits with our formulas in order to find out how many subnets we had, as well as how many hosts we have per subnet. And then finally being able to find out where each of our network IDs are, where our subnets increment, where each of our broadcast IDs are, and what our potential and usable hosts are within each of those subnets.